Hello everyone, this is a continuation of the Split the Sums video. I again had something busy that I was doing yesterday, so now it's just the continuation today. Anyways, let's get to the solving. Okay, so, um, I think these numbers are correct. Let's go from just the analysis. So again, the tentropy line, the difference between, so you can start with the sum of, we know that the total of the tentropy line adds up to 40. So it starts at even 2020. But each change of a digit, you can either change from 1 to 9, 2 to 8, 3 to 7, or 4 to 6. Those differences are even. So you can only get a change of sum from like in by even sums. So it has to be 20 to 18 and 22. And then the next one out is 16 or 24. But if the problem, if you have 16 and 24, they're not going to be able to form a Renban with the other sums because there's only 8 lines. So because if you have 16, 17, 18, 19, 20, 21, 22, 23, 24, you require 9 sums to make it consecutive. So therefore, we are guaranteed this is 18 and 22. Because it's 18 and 22, we know the parity line must add up to 45 because there is each constraint may contain a no repeated digits. So to have no repeated digits for 9 cells on the constraint, it has to add up to 45, which is the sum of 1 through 9. So 45, you have 18 and 22. Therefore, you cannot have 22 and 23. Adding up to 45. Let's just reset this. Keep time. So this is 18 guaranteed, and this is 22. You cannot have 22 and 23. You could have 21, 24, or 20, 25 technically. But again, the Whisper 5 line, you have 7 digits on that. That means it goes to at most. Again, you can't have. That means you're missing a 5. You cannot be missing 1 or 9 because if you're missing 1 or 9, you're guaranteed to have a 4 or a 6 with it. And 4 can only be next to 9 on a Whisper 5 line. 6 can only be next to 1 on a Whisper 5 line. So if 1 or 9 are removed, the 4 or 6 cannot be next to any digit, which means there's going to be a contradiction there. Or there's going to be a duplicate, which is not allowed. So that means 45 minus 5, because 5 can never be on a Whisper 5 line, is 40. That means it's at most 38. The difference you can have between the 38, I think we proved it earlier, you can't have that anyways. But say we try 20 and 25 with 18 and 22. 38, it can only be 19 and 19. You can't have 18, you can't have 20, so then it would force it to be 17 and 21. And then 17 through 25 is too large for 8 lines to be a consecutive set, right? 17, 18, 19, 20, 21, 22, 23, 24, 25 is 9 lines, 9 sums. So we guarantee then this has to be 20, 18, 22. It cannot be 22, 23. It cannot be 20, 25 because then the Whisper 5 line doesn't work. So it has to be 21 and 24. And 21 is the 5 length line because you have to have odd, even, odd, even. So this is odd, even, odd, even, and then odd. Because we have to have... You can't have 3 evens here, because then you would have only 1 even for this set of 4. And it alternates parity. So, this is 21 guaranteed, and this is 24. These we don't know about. So since this is 24, it cannot be 16, 17, 18, 19, 20, 21, 22, 23. It has to be 17 through 24. Therefore, and again, you cannot have 18 here. So, okay, this relies on what is missing from the Whisper 5 line, right? So if you have 2 missing, so 17 is the smallest any 3-digit number, any 3 digits can be on the Whisper 5 line. So this, therefore, you cannot have a high and 2 lows here. Because if you have a high and 2 lows, that's at most 9, 3, and 4, which only adds up to 16. So this must be a low and 2 highs here. That means in this, we have high, low, high, low. We are missing a low digit, which means it can be missing 2, 3, or 4. Maybe I messed this up because it doesn't have to have 17 be in this set. Oh no, it kind of does. Well, okay, we know 4 can't be here. 1 can't be here because it must be next to the 6, because we have all 6, 7, 8, 9 on the Whisper 5 line, because this is even with 2 odds. If it's odd, I'm sorry, low with 2 highs. If it's high with 2 lows, it's, again, at most 9 next to 3 and 4, which is only 16, which is too small of a sum. So this must be low with 2 highs. It can't have 1 because you need a 6 on the Whisper 5 line, and this would then be 6, 1, and 9 at most, which is 16, which is too small. So this must be 2 or 3 here. That means 6 and 1 have to be somewhere along here. So this is 6 with 1 being one of these, or 6 being there. So what are the possibilities here? You can't have 18. 3 is necessarily next to 8 and 9. So if this is 3, it's 8 and 9. Which means this must be 1, 2, 6, 7. But 1, 2, 6, 7. So 1, 2, 6, 7 adds up to 13 plus 3, which is 16, which is too small. So this can never be 3, then this is guaranteed to be 2. It cannot be 2, 8, and 9. Because if it's 2, 8, and 9, that would guarantee you have a 7 as the other high digit here. And 7 can only be next to 1 or 2. But it can't be in the middle then. 1, 7 would be next to guaranteed at least 3 or 4 because 2 is already taken. So it cannot be 2, 8, and 9. If it's 2, 7, and 9, that adds up to 18. So it must be 2, 7, 8 then to add up to 17. So this is guaranteed. So then this becomes 1 and 9. And this is either 3, 6 or 4, 6. Oh, maybe this was the problem that I ran into. So this is either 19 or 20. We have 21, 23. So we have to have a 23 somewhere. And Yeah, this was the problem. So this has to be 20 then. So this must be 4, 6, 1, and 9. And then this must be 19. Right. Okay, so the remaining digits in row... Again, this cannot be 5 and 5. Or it cannot be 2 mod 3 here. So we have 1, 3, 4, 5, 6, 9. 1, 3, 4, 5, 6, 9. So we tried to have 20. That doesn't work. It can't be 23 and 20 because of the issue that we were... This can't be 5 because you can't have two mod 3s here. And they have to be the same set. If you have 3, 6, and 9, this would be a combination of 1 mod 3 and 2 mod 3, which adds up to a 0 mod 3. So this sum would have to be 0 mod 3, but the only 0 mod 3s are specifically 18, 21, and 24, and we have sums already of that. So it cannot be 3 mod 0 mod 3. This must be a 1-4 pair, which eliminates 1 and 4 in the rest of the row. This can't be 6 because it has to be odd. So this is 1 mod 3, 1 mod 3. So it cannot add up to 23 because that's too many. 5 plus 23. So this is not 23, therefore the other one has to be 23. And this must be 5. And one of these, and then this has to add up to... We can't have 17 or 18. 20 doesn't work, so because again, that would have to be 7 and 8. Because these have to be different sets, we have to have at least an 8 here, or 5, and that's not possible. So then this must add up to 19, which makes this 5 and 9, I believe. So this has to be 20 that it adds up to. Which means this is a 4-6 pair here, and not a 3-6 pair. Yeah, so that was the issue that we ran into there. To add up to 19, you have 2 digits. It could be 6 or 8, or 5 or 9. So 5, 6, 8, oops. This is 5, 6, 8, or 9, and we're not sure which is which. Okay. So this becomes a 1-4 pair. That means we are, and again, this is 19 and 23. That adds up to a total of 42. So we're missing a 3 on this Whisper 5 line. So that means we have to have, this has to be 2, 5, or 8 remaining here. And we cannot have a 3 here, so this must be 7 with 6 or 9 here. We're not sure which. We're guaranteed one of these is a 7, though. So one of these is 7. This is 15 plus 5, which does add up to 19. We have 2 and 7 here, which is 9. And then it's either 5, 9, or 6, 8, which adds up to... right. 23. So this the problem was basically I had this at 19 when it should be 20. Okay, so that's the issue there. Remaining digits in this box are 2 through 8, but these cannot be 4 or 6 because of this is going to be 1, 4, or 6. This is going to be the other one. Okay. This is even. So the 2 has to be one of these two. We don't know which. So 2 is guaranteed to be one of those. This is 7, 8 as a pair. This cannot have a 5 on the tentropy line. So it's 3, 6, or 9 there. That means we can't have well, we could have 3, 6, or 9. We just can't have that. Okay, so this digit cannot be 1 or 4. Okay. So this has to be... This adds up to 24. Uh, This is guaranteed to have a 2, so the remaining 4 digits here must add up to 19. Can you have it without a 1? 2, 3, so it would be 357. Yes, you could have 357, and can you ever have a 9? I guess 159 with 4 works. Huh. If this were 1, this would have to be 9, and then this would be 4, and that would eliminate all possibilities for this cell. So this cannot be 1. It's 9 here, which makes that 4, which makes that 1, and that's 6. We can remove 4 from the rest of the box. And we know this can't be 6 or 9, and this 6 eliminates 6 and 8 as a pair, adding up to 14. So this has to be 5 and 9, which eliminates 5 in the rest of the column. That also, 9 eliminates 9 here, so it's a 6, 7 pair. And this cannot be 5, so this is a 2, 8 pair here. Okay, this is 6, 7 as a pair, which eliminates 6, 7 in the rest of the row. Therefore, where is the 6 in box 3? It must be one of these 2 digits here, which means 6 has to be one of these 3 digits here. We have 5 and 9 here. This is 6, so this can't be 6. It's 2, 4, or 8. 2, 4, 6, 8. 1, 3, 5, 7, 9. This can't be 1, so it's 3, 5, 7, 9 there. Okay. This is 6, 7 as a pair. Okay. What else do we know? This is 24. One can't be either of these. One cannot be here. Oh, these both see 2 and 8. So neither of these can be 2 or 8. Therefore, where is one of these has to have a 2 or 8. It must have an 8 here then. So this can't be 2 or 8 because these are 2 different digits. And they're 2 and 8. So that then they both see these cells. So 8 has to be one of these 2. Which means 2 has to be somewhere along this entropy line. So we have a guaranteed 2 there. We have a guaranteed 8 here. To add up to 18. Well, we don't know if this is 18 or 22. So this has 8. Can you add up to 18 with it? That means the 3 remaining digits must add up to 10. Obviously, 9 doesn't work. 174 doesn't work. 136 does, though. So this could be 136. Interesting. 8 does not belong here. Remaining digits of row 2 are 1, 2, 3, 4, 5, 8. Okay. 1, 2, 3, 4, 5, 8. 2 has to be one of these 2. 2 is one of these 3. So we have a guaranteed 8 here. This can't be 1. So we have 3, 7, 4, 6, or 9 here. This could be a lot of things. Okay. All four of these cells see the 6, 7 that's there. Can you have 8 and 9 together? That adds up to 17. And then the minimum would be 8, 9, 3, 4. So the answer to that is no. Right? 8 and 9 would have to be with 3 and 4 on the entropy line. But that's too big. That adds up to 24. And we already have a 24. So then this cannot be 9. This is then guaranteed to be 3, 7, or 4, 6 here. Therefore, this must be 8 and 1 as a combination. So this is 1 and 8. That adds up to 9. So it's either 3, 6 here. Hold up. It cannot be 6 and 7. It could be 6 and 7. Okay. So I think this is guaranteed to be 6 here. Right? To add up to 18, you have to add up to 9. So it's 3 and 6. To add up to 22, 22 minus 9 is 13. So it has to be 6, 7. But we can't be 6, 7 because that would eliminate all possibilities for this cell. So then this must be 3 and 6, adding up with 1 and 8 to add up to 18. So this can't be 6, this is 7, this can't be 7, it's 6. Okay. That means this cannot be 3 or 6, it's guaranteed to be 9 because of the global regional constraints. So this has to be 2, 6, and 4 here. Sorry, no 6. 2, 4, and 7. And that adds up to 22. So 2 and 9, 4 and 7. Yeah, so this cannot be 4. Can't be 6 anymore either. This 9 eliminates 9 from the rest of the row. So no 9 here, no 9 here. This adds up to 21. Okay, this 9 eliminates 9 here. This 3, 6 pair eliminates 3 and 6 in the rest of the row. So no 3 or 6 here. So no 3 here because of the 3, 6 pair. No 3 here, no 3 here, no 3 here. Oh wait, no, this could be 3. These could all be 3. So where is a 6 in box 3? It has to be there. 6 is one of those two. We know this adds up to 24. So this is guaranteed. So this is done. It adds up to green. This is done. These two are done. This adds up to 23. Okay, all of these are done then. So now we just need to figure this part out. You could have a 9. You could have 3, 5, and 7 here with 2 and 4. That does add up to 21. Oh, this cannot be 1 here. So we're guaranteed the 1 on this set, which means this cannot be 1. So then this does have to be 3, 5, and 7. Because 9 cannot be here. Which means this is a 1, 9 pair somewhere here. And it must add up a 24, so we have to have 6 and 8 here. To eliminate 6, 8 in the rest of the box. So this can't be 8, this is 7, this can't be 7, that's 8. This can't be 6 anymore, it's 3 or 5, and we have 3, 4, or 5 in the rest of the box. So this can't be 6 or 8, it's definitely 2 and 4 as a pair. This is 3, 5, and 7. We have 8 here, we're guaranteed a 4 here. We don't know how this works. This is 3 and 6. Remaining digits in column 3 are 3, 5, 6, and 9. But this can't be 3 or 6, so this is 5 or 9. Because of the 3, 6 pair in the box. And this is 5 or 9. This has to then be... The 5, 9 pair eliminates 5 and 9 in the rest of the column, so this can't be 5 or 9. It's 3, 4 as a pair, which eliminates 3, 4 in the rest of the column. Therefore, that makes this 6. And this 3, 4 pair eliminates 3 here, so it's 5, which eliminates 5 here, so it's 3. This can't be 3 anymore. This can't be 3 or 5. It's 6, which eliminates 6 in the rest of the box. We have a lot of 6s now. This 5, 9 pair eliminates 5 and 9 in the rest of the box, so this has to be 1, 2, 4, or 8. No 4 here because of 4 in the row. So 4 has to be one of these two digits here, which eliminates 4 in the rest of the row. Where is 4, then, in row 3? Can't be here because of 4 in the box. Can't be here because of the entropy line, and the 4 having to be here, so 4 has to be here. So this is 4. Okay. We have a 2, 5, 7, 8 quadruplet in row 3, which eliminates 2, 5, 7, 8 in the rest of the row. So this can't be 5. This is 9, which makes this 5. Okay. 1, 8, 6 here. 5 has to be one of these 3. 3 cannot be here. 6 can't be here. Okay, where's 6 in box 5? Can't be here, can't be here because of 6s in the rows and columns. Can't be on the parity line, so 6 has to be here. Okay. And we're pretty much done. We just have to probably do normal Sudoku somewhere. These cannot be 2 or 8 because they see both of these 2 or 8s. So what can it be? It could be 1, 3, no 2, 8, no 4, 5, 6, 7, or 9. Okay. So we're guaranteed a 9 there. We don't know about anything else. Okay, these digits, this digit sees, these two digits see all of these digits, and there has to be 2, 4, and 7 there. So these cannot be 2, 4, and 7, and it can't be 3 and 8. So the remaining digits we have here, we have 6 here and 6 here. Where's 6 in column 5? Can't be here because 6 in the boxes. Can't be on the entropy line because we already have a 6 there. So 6 has to be here, which means this cannot be 6 here. So we have a guaranteed 6 here, which means one of these is even, and therefore 8 cannot be with it because then it would have 2 evens next to each other. So 8 has to be one of these two. Okay, and then this cannot be 6, 2, 4, or 7, or 3, 8, 9, so it has to be 1 and 5 as a pair. And this 2, 7 has to go here. So this digit is the same as this one. We can remove the coloring here because that's not helpful. So this is the same as that. This is 1, 5 as a pair, which eliminates 1, 5 in the rest of the row. So this can't be 1, therefore this is a 6, 9 pair, which eliminates 6 and 9 in the rest of the box. So that's a 1, 8 pair there. Remaining digits of row 8. No 1, 5, no 6, 9, no 4. So it could be 2, 3, no 1, 4, 5, 6. Could be 7, 8. Okay. Where is 9 in column 7? Can't be here because of 9's in the boxes. Can't be on the line because we know this is a 9 because it can't be 3 or 6. Can't. This is a 6, so this must be 9 here. We need a 5, then somewhere in box 9. Cannot be here because of 5 in the box. Can't be on the tentropy line. And this 1-5 pair eliminates 1-5 from being here. So 5 has to be here, which eliminates 5 in the rest of the column. So now, where's 5 in box 3? It has to be here. So this is 5, which eliminates 5 in the rest of the row. Where is 5 in row 3 then? Can't be here anymore, so it has to be here. So this is 5, which makes this not 5, because you can't have repeats on the restraints. So this is 5, that's 7, which eliminates... So this has to be a 7 here, which means this can't be 7 here. So this is 7 or 9. This can't be 7 or 9 here. We have a 1, 2, 3, 8 quadruplet in row 1, which eliminates 1, 2, 3, 8 in the rest of the row. This cannot be 1 or 3. This can't be 1 or 3. It's 7, 9 as a pair. This 7 eliminates 7 as a possibility there. We have a 2, 4, 2, 4 pair in column 5, which eliminates 2 and 4 in the rest of the column. So this can't be 2. This is 8, which makes this not 8. That's 2. So that eliminates 2 in the rest of that box and row. So this can't be 2. 8 eliminates 8 in the rest of the box here and the row here. So this can't be 8. This 2, 4 pair also eliminates 2 and 4 in the rest of the column. So this can't be 2. This is 1, 3 as a pair, which eliminates 1 and 3 in the rest of the box. So this can't be 1 or 3. It's 2. So that eliminates 2 from being here. So 2 is here, which eliminates 2 here. So this is 4, which eliminates 4 in the rest of the box. So that's 2, which makes this 4. So this cannot be 2 or 4. It's 7, which means the yellows are the 2s. So these are 2. That eliminates 2 here. No 2 here, no 2 here. 4 eliminates 4 here. So this is 3, this is 4. 3 eliminates 3 in the rest of row 8. So this is 7, 8 as a pair, which eliminates 7, 8 in the rest of the box, so this must be 3. So we have 3 here, which eliminates 3 in the column, so that's 8 and 3. 8 eliminates 8 here, so it's 7 and 8. 7 eliminates 7 here, so it's 2 and 7. 8 eliminates 8 in row 1, so this is 1, which makes this 3, which makes that 1. 1 eliminates 1 from being here, so this is 8, this is 1. 8 eliminates 1 and 8 here, so it's 4, which makes this 8. This 8 is even, so this must be odd, so that's 9 and 6. 6 eliminates 6 here, so it's 3 and 6. 5 here eliminates 5 here, so it's 1 and 5. 7 here eliminates 7 in the column, so it's 9 and 7. And the rest we can probably do from Sudoku. In fact, we have to do from Sudoku because we don't have any other additional information. So where's the most information we have? It's column 6, and this has to be in 8. And column 5 has to have a 5. We have, this is 1 or 4, and it still has to be 1 or 4. Everything else has 6 clues. Okay, let's just go with an order. We have 2, 7, 9 here. And this cannot be 2 or 9. So this must be 7. Therefore, there's no 7 here, no 7 here. Remaining digits in column 2 are 3, 4, and 5. This can't be 4 or 5 because of 4, 5 in the row. So this is 3. This can't be 5 because of 5 in the row. So it's 4, which makes that 5. Okay, column 4. We have 1, 3, and 9. Well, actually, it should be row 6 now because we have that. So it's 1 and 3. This can't be 1 because of 1 in the column. So this is 3, which makes this 1. And this becomes 3 and 9. This can't be 3 because of 3 in the row. So that's 9 and 3 there. 9 eliminates 9 here, so it's 2 and 9. The remaining digits of... Let's do row 7, or column 7. We have 1, 2, 3, 4, 5, 6, so it's 7 and 8. This can't be 7 because of 7 in the row, so this is 8, which makes this 7. which eliminates 8 here, so it's 1 and 8 here. That makes this 4. That leaves us as 2. We have 1 here, which makes this 4 and 1. Yeah, not too bad, actually. The logic behind it was fairly... the only thing I missed was, and this took me a longer time because of it, was that the tentropy lines could only be 18 and 22. Once you get that, that will clear a whole bunch of information, right? So, yeah, I didn't. Yeah, I should have focused. Well, it's hard to know, right? Anytime you have a new puzzle, it's just like, wait, what does this mean, right? So it's hard to figure that out from the beginning. I guess I would still classify this as very hard because you have to get to know that. There's no like intuition that you can come up with that will basically derive that. You just have, well, maybe there is. Maybe if you have enough thought about it, you should be able to, but I just don't. So, that's on me, I guess. But once you get that, it's actually fairly straightforward to solve this. But trying to understand that and thinking that through. I tried all the other lines before I did the tentropy line, which was probably the mistake. Or I should maybe have thought of it harder. I did narrow it down to 1723, 1822, and 1921. But I didn't really think through what it meant to have the tentropy line force that, right? I don't know. To me, it doesn't really seem very hard, but maybe that's, I mean, but if you look at the amount of time I spent, that's essentially the amount of time you would spend on a very hard puzzle. So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.